Hello, I'm audible to you guys.
Yes, ma'am.
So today we will just start the basics of data structure and important subject. Have you all gone through your syllabus? All of you, have you gone through your syllabus?
Yes, ma'am.
So if you see your syllabus, so your first uh, module is with the introduction of like basic terminologies and different electrical data organizations and all. The definitions first. Can you see this way? Detail. Can you see the screen?
Yes, ma'am.
So first we will go through a little bit basics of data structure. I guess you guys already know what is a data structure. Anyone wants to tell it again? What is a data structure? Roll number 0. Can you tell me what is a data structure? Just your idea. Roll number 2. Roll number 2. Can you hear me? Roll number 1. Huh. Someone just left. Roll number 19. Any idea?
Ma'am, it is a way of storing data, I guess.
Yes. So data structure is nothing but an organization how you can store your data and information. Okay. So without the data structure, the algorithm is not complete. In last semester, we have already discussed what is an algorithm. Algorithm. What is an algorithm? Sneha says.
What you say?
What is an algorithm?
Zeros and ones, binary algorithms.
Algorithms. That's your binary code. Algorithm. What is an algorithm?
Uh, it was when, ma'am, I think some rules.
I think. Don't say I think.
Ma'am, no, yes, ma'am. It's some rules to follow doing problems to solve problems or operations, basically for
Number
computers.
24. Pranjalas, can you tell me what is an algorithm?
Ma'am, it puts the all the
কি
Ma'am, I think it's
যোনবিলাক
like an
বস্তু আমি
formula.
বিচাৰি আছো সেইটো ডাইৰেক্ট
কি 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 দুটা ওভাৰলেপ
মানে যেনেকে
কোৱা একো নাই
মেম লাইক মেম মানে এক্সাম্পল মানে যেনেকে ইউটিউব এলগৰিথম থাকে মানে যোনটো বস্তু আমি সাৰ্চ কৰি আছো সেইটো
Mm,
লাষ্টত আহি যায় মানে
I
নৰ্মেল
think
সাৰ্চ কৰোঁ
algorithm is like a formula which show us the by which we can show the steps how to conduct a program.
yes correct if you are going to write a program you have to know what should be the algorithm is
What are the steps?
step by step method or process or the rules through which you are going to execute your programs. So without knowing the algorithm, you cannot write the programs. Like remember last time I gave you examples like even if you want to open a bottle, first what you have to do, you have to pick up the bottle, then you have to open the cap, then you will drink water, then put back your bottle into your desk, right? So simply if you write a program to add two numbers, what you have to do first? Remember for algorithm, we always start with the start and in the end we write end. Then in between the body part comes like a declaration of variables, right? Then you write the main code. Like if you want to add two numbers, then you take one variable, suppose A, then A equal to B plus C and on. So algorithm is the rule or step-by-step method to write the programs. Okay. Now, when you write the program, now you have program, you have algorithm. So after knowing the algorithm, you can write the program. Now, what is a data structure? Remember last time you guys used variables. There are some values to your programs. Okay. So data structure helps you store your data. Okay. Last time we learned about array. Array is one type of data structure. You know about the primitive data types like int, boolean, float, and all. Right? So now in this semester, you are going to learn about more abstract data structures. Okay, more advanced. So the relation between data structure and algorithm is that they are complementary to each other. Okay, write any programs if you want to store your data elements in an efficient way and in an organized way, then we have to use the data structure. Okay. So data structures are the main part of many computer science algorithms because they enable the programmers to handle the data in an efficient way. So it basically will help you to enhance your program. If you use a good data structure, then your program will be more efficient. It will be faster. Okay. Now we have different organizations for data items. Okay. What is the data? Normal data. Data can be like your any elementary values. Right? It can be collection of values like your name, your IDs. Those are data. Remember for structure, there are different variables you use. We can keep the records of employees or students. So name will be a value. It's a data. Your enrollment ID is a data. Okay. These are the data. Then what is the data items? Data items are also known as group items. Data item, simply the single unit of value. Okay, so data items can be again divided into subgroup items. Like for example, your name, sometimes even in form you can see your names have like divisions: first name, middle name, and the last name, right? So as a whole, your name is uh, your data, but again we have first name, middle name, last name. These are like your group items. Okay. So data item, sometimes there are some elementary items also, and those elementary items you cannot divide. For example, like your uh, some values, suppose book number or your SSN number. Okay, those things you cannot divide. Okay, these are elementary items and you cannot divide them. So data items which have like subordinate data items are group items or the data items. Okay. Then we have also entity. What is an entity? Entity is something that has like certain attributes or properties which may be assigned values. Okay, for example, like your name. Again, your name can be an attribute to some uh, name is an entity, then you can put your name there. Then in a form, there will be again the age, then there will be your enrollment ID, and there are different formats. So you will add values to those things. Entity, like name is an entity, then age will be an entity, your gender will be an entity, and so on. So entities with similar attributes will form an entity set. Okay. So each attribute of an entity set has a range of values, and the set of all possible values that could not be assigned to the particular attributes. Okay. Then we have field. What is a field? Field is like single elementary unit of information representing an attribute of an entity. Like your whole form can be a field. Maybe there will be a portion where you have to provide your personal address. So that whole thing is the field. Personal information is the field. It runs classroom. Okay, sorry, the disturbance. Okay, so field, what is a field? It can be a like single portion of your form. You can just think about the form. If you see the field where you need to provide your personal information, that can be a field. Okay, so field is like single elementary unit of information representing all the attributes of an entity. Then comes the record. So what is a record? Record can be like collection of various data items. For like, remember in again we are going to the structure and union thing, student entity. The whole personal information is a student entity. So there can be your name, address, your post, marks, everything can be grouped together. Okay, so that can I can say it's a student record. Yeah. Then comes the file. So files will be again the collection of various records of one type of entity. For example, there are 32 students in your class. So all records can be think as a file. Okay. So there will be like 32 records and I keep everything in one file. Remember, I gave you the link for your post registration thing. So that is a whole file for your post registration, and each of the post registration information is a record. Okay, so these are just so this is like your formal definition of a data structure. Okay, a data structure can be a logical or mathematical model of an organization of data, and which we call it as a data structure. And data structure is already we mentioned, it's mainly used for storing and organizing your data so that you can use it efficiently in your program. Okay. Now we have different types of data structure. So mainly there are two types of data structure. One is primitive data structure and one is non-primitive data structure. Primitive data structure you guys already know about. Those are int, character, float, and double. All those data types, the basic data types are the primitive data types. Then comes your non-primitive data type. So non-primitive data types are like which can be created with the help of your primitive data structures. Okay, so primitive data structures are already there. So with the help of primitive data structures like int, character, float, we can create different types of, or that means non-primitive data structures. Okay. মই মুখন কাইলৈ দিম স্যার আপোনাৰখনত চাইন লাগিব আপোনাৰখনত চাইন লাগিব Okay, so non-primitive data structures can be created with the help of primitive data structures. Again, in non-primitive data structure, we have two types. One is linear and other is non-linear. Again, from linear, you guys already know about array. Remember, it's a linear type of data structure with the similar items. Alright. So in the same thing, in same linear type of non-primitive data structures, we have stack, we have queue, and linked list. Okay. Then in non-linear data structures, we have two types. One is tree and other one is the graph. Tree and graphs is like almost similar. Trees are like branches and nodes, and graphs are also same. Just that in graph, everything is like connected one. Means those are closed, and tree is not closed. Okay. Any confusion till here? Data structure types and all.
Clear, ma'am.
So in linear type also, we have another two things. One is static type of linear data structures and other is the dynamic. Your array is the static one. Okay. About array, we have already done in the second semester. So array is not a primitive data structure and is also static. Now here we will learn about dynamic data structures like stack, queue, and linked list. So here, it's just again, I already mentioned primitive data structures are like fundamental type and it consists of characters and it cannot be divided. These are like built-in data types. Okay. Examples you guys already know. It can be integers, boolean, it can be floating, it can be characters and strings. These are all primitive data structures we have already learned about. Then in non-primitive data structures, already mentioned about that, it can be created with the help of primitive data structures. And they are implemented independent and they are also known as derived data types. Okay. So from linear data types, we have like sequence of linear lists. There are two ways of representing in memory. One is sequential memory location or pointer or link. This array, stack, and queue. These are sequential. Okay. And for the linked list, we have separate pointers and the links. So when we will learn about the linked list, again those pointer concepts will come here. And for nonlinear data types, already mentioned, two types. Examples are like tree and graph. And these are not arranged in sequential manner. Okay, it can be just here and there. Maybe one node is here and another node is stored in somewhere else. Just that there are some relationships between those nodes. Okay, so it will have some hierarchical relationship. There will be parent, there will be children nodes. So key data structure is something like with your family trees, grandparents, parents, children, siblings, and all. So these are like overview. We will go through each of these one by one. So after knowing this, what will be the need of data structure? Advantage, you can already see it will be memory efficient. Okay, it can optimize the memory you are using. So it will increase the efficiency of your program. Okay, so if you select a good data structure for your program, the efficiency of your program will rise exponentially. Okay, so for example, suppose we have some data, we have to perform the searching in a particular record. Okay, now you guys already know about different searching methods, right? So if we organize our data in an array, we will have to search sequentially element by element, right? Normally in linear search, we just store all the data in an array. Even for binary search, remember we use an array, right? Then we just search for a particular item sequentially one by one. Okay, so you can see using an array, use of array in terms of searching might not be that very efficient. Okay, so there are better data structure for that. Okay, instead of array, we can also use trees, tree data structure or hash tables. Okay, trees or binary trees, binary search tree is there. When we will go through the tree chapter, we will learn about the binary search tree. But for just know that for searching, instead of using array, if you use tree data structure, it will be more efficient. Okay, in an array, it's a sequential process. You have to search it one by one. Okay, but in case of tree data structure, we don't have to go like one by one. So it will be more efficient data structure. Okay. If you want to use different data structure, there are also some ordered array. Okay, there are so different types of array with not exactly sequential but ordered array. Okay, then we have also hash tables. We will also learn about that type of data structure. And another advantage is that reusability. Why do you think the data structures are reusable? Anyone wants to say? Why is it reusable? Anyone? What do you think? Why is it reusable?
Then we can get additional performance benefits.
Reusable, just follow the word reusable. Even it's written here, it can be reused. So you only need to design your data structure once, then you can just use that same data structure any place in the code. Like in case of like variables, like your primitive ones, you have to assign a variable every time you store a value, right? Like again, in case of like structure and all, you have to define different structure for every record. But here in data structure, uh, it helps. You can use this. You need to implement just one. Okay, then you can just use it in any other place. Okay. And later on, it's not only usable by you. If once you create it, then you can also compile to libraries. Other different clients can also use your data structure. Then comes the abstraction. So abstraction means you will see in your syllabus there is a term written ADT. ADT means abstract data type. Okay, abstract data type means it provides a level of abstraction. Okay, so the client program uses the data structure through interface only without getting into the implementation details. Okay, so your data structure provides an abstraction so that obviously when you write program for any purpose, you are going to give it to a client, right? So your client can directly access it with just interface. They don't have to know about the implementation, like how you build that data structure, how you organize the data there. Okay, so it provides the abstraction. So, okay, now we can perform different operations in a data structure. So advantage is clear to everyone. I guess it's clear. Just it will increase the efficiency of your program. You can reuse your data structure anywhere else in the program, also accessible by the other clients. Then it provides the abstraction. That means for the client part, they can just access it through the interface, no need to know about the implementation part. Okay, so there are different operations we can do in a data structure. Okay, so these operations are like common in all types of data structure. We are going to learn later. Okay, one is traversing, searching, insertion, deletion, sorting, and merging. And just from the name itself, you can just understand what it is. Right? Traversing means what? Traversing means you are going to visit each and every element stored in the data structure in some particular fashion based on your particular operation. For example, you are searching for something, like in your binary search and in search, you are searching for a particular item, or even in sorting, you have to sort the data in increasing or decreasing order. Okay, so traversing will be like before searching or sorting, you have to traverse through each of the elements stored in the data structure. Okay, that means you are visiting each element stored in the data structure. That's the traversing. Searching, you already know. Searching means you are just trying to find some element in a particular location. Is the searching. And there are two types of searching we already know about: linear search and binary search. Now, apart from that, we have insertion and deletion. Okay. Insertion means, see, remember I mentioned stack, queue, and linked list. These are dynamic data structure. That means you can add items later at any location. Okay, so insertion means you can add elements to the data structure at any location. Okay, and similarly, deletion means if required, you can delete any data from your data structure from any location. Okay. So if your data structure size is n, so how many elements you can insert for an n? If your data structure size is n, how many elements you can insert in a data structure? Anyone? The same concept you used in array. Just use the same logic. The size of your data structure is n. Then how many elements you can enter in your data structure? Roll number 27. Partially, yes, it's n minus 1. The simple one, right? If your size is n, Means, for example, your array size is 5, then you can enter 4 elements because index will go from 0 to 4. If the size of the data structure is n, then you can insert only n minus 1 data structure in your data structure. So when we deal with the insertion and deletion, there are certain terms. One is underflow, one is overflow. Okay. So what is underflow? What is the underflow? Underflow term occurs normally in case of deletion. And overflow comes when we want to insert something. Okay, as I said, size of your data structure is n. Okay, and your whole data structure is already full. Okay, then you are still trying to insert elements to your data structure. So that condition is known as your overflow. Just think about your bucket of water. Your bucket can just hold certain amount of water, right? Bucket can just hold certain amount of water, right? So once your bucket is full, after that also you keep pouring water on your bucket, then it will be overflow. It will come out of your bucket, right? So it's the same concept. If something is already filled and you are still trying to fill up something, it's a overflow condition. Okay, and another term is the underflow. Underflow means there is nothing inside your data structure and you are still trying to delete something. Okay, it's like your bucket is already empty and you are trying out to empty out completely. There's nothing there. That's your underflow condition. So these two things are going to be used whenever we will learn about different operations in the data structure. Okay. Underflow and overflow. Is this clear to you? What is underflow and what is overflow? Underflow and overflow.
Clear, ma'am.
Okay, good. So sorting, you guys already know, it means arranging the data in data structure in particular order. Now comes the merging. Merging means suppose you have two different trees, then you just want to merge it. Just that you need to check the size of the new end. It's like your matrix one. Suppose you have matrix A, then you have matrix B. Then you always just declare another matrix to hold the addition of two matrices, right? So it's a merging process. Merging means just to merge a list, but both lists have to have like similar types of elements. So that's all for today. I hope the basic is clear to everyone. Just the reasons. For next class, we will learn about algorithms. Next, we will finish your unit 1. Then we will do the next module. Okay, this part clear, right? If you have any confusion, you can ask anytime. I'll just give you the notes for this, whatever we taught here. Just give it immediately. Okay. Distortion. Attendance. Switch on your videos for a while. Switch on your videos. it's quite close to the one essence. Okay, I hope this part is clear to everyone. If you have any doubt, you can ask. To put up the details. Okay. There will be no lab class today. We will start lab class maybe after 1 or 2 weeks. Means we have to learn a bit first before starting the lab. Okay. Okay. Thank you all.
Thank you.